Tests for cations, particularly metal ions, often involve observing characteristic colors produced in flame tests or the formation of colored precipitates when sodium hydroxide is added to their solutions. Flame tests are a quick and simple way to identify certain metal ions based on the color they emit when heated in a flame. When a metal ion is exposed to a flame, the heat provides energy to excite the electrons within the metal atoms. As the electrons return to their ground state, they release energy in the form of visible light, and the color of this light is unique to each metal. For example, lithium ions produce a crimson-red flame, sodium ions yield a bright yellow flame, potassium ions produce a lilac or light purple flame, calcium ions give an orange-red flame, and copper ions create a green or blue-green flame. To perform a flame test, a clean platinum or nichrome wire is dipped into a sample of the metal compound, then placed in a non-luminous Bunsen burner flame, and the color observed can help identify the metal ion present. Some metal ions can also be identified by adding sodium hydroxide, NaOH, to their solutions, which often results in the formation of colored precipitates. When NaOH is added to a solution containing metal ions, the metal cations react with the hydroxide ions to form insoluble metal hydroxides. The color of the precipitate that forms is specific to the metal ion present. For example, a white precipitate indicates the presence of calcium, magnesium, or aluminium ions, although aluminium hydroxide will dissolve in excess NaOH to form a colorless solution. Iron, 2, ions produce a green precipitate of iron, 2, hydroxide, while iron, 3, ions form a brown precipitate of iron, 3, hydroxide. Copper, 2, ions give a blue precipitate of copper, 2, hydroxide. These tests, both the flame test and the reaction with sodium hydroxide, are important methods in qualitative inorganic analysis, helping to identify and distinguish between different metal cations based on their characteristic colors and reactions.